Hello everyone and welcome to this week's lesson, and we're going to talk about algorithms, how you and computers think. Now to start off, let me ask you this question. What results would you get if you search Google for the nearest ramen restaurant? You can pause this video if you want to search for this keyword. What results would you get? Have you ever wondered how these search results are being ordered? Because typically, the first thing that we see are the first ones that we actually click, right? So if it's the top one result, then probably that will be one of the reputable links to go to. So if you notice, there is a chart on the right, components of Google's ranking algorithm. So if you notice, the different elements of this pie chart shows you the priority of Google when ordering your search result. So first, it is based on trust, authority of the host domain, which garnered 23.87%. Link popularity of the specific page, so around 22%. Anchor text of external links to the page, that's 20%. On-page keyword usage, that's 15%. So without really going to every element of this pie chart, you would know that the basis of our search results are based on trust or authority. So if it's a really reputable website, like for example, you're searching for news, you're searching for certain restaurants, maybe, there are popular websites that shows you some reviews. That would be probably one of the first links that would appear in your Google search. So it actually follows a certain order every time you search for something. So that's how somewhat algorithms work. Now, another question, how do you prepare an instant pancit canton? You can probably think of different types of food, but this would be one of my favorite snacks, even when I was still studying. How do you prepare an instant pancit canton? And probably this would be an easy procedure because it's already instant, right? So you just have to have the packet, you just have to have the noodles, and of course you just pour on the seasonings. So there could be certain instructions or steps that you must follow in order to make a successful and delicious snack or pancit canton. So there is an actual online activity related to this. So probably you just have to check your synchronous session for this activity. Now next, if you're thinking about ways on solving a problem, you are planning to make an algorithm. So I think everyone has at least encountered a problem once at least in their lives. So in one way or another, the solutions that you think of and the steps in order to solve that particular problem could be called an algorithm already. So to give you a more formal explanation what an algorithm is, it's a formula or set of steps for solving a particular problem. Algorithms must be clear and must have an endpoint. So if you have a problem, at least maybe what's the first step and what will be the last step? Or probably something in between that you have to decide on something. Okay? So that process is already what an algorithm is. Algorithms can be expressed in any language. So natural languages like English, or maybe symbols, or programming languages like when talking to a computer you need a programming language. So in this for this year we're going to use Python as our way to communicate with our computers. So we use algorithms every day, most programs, with the exception of some artificial intelligence applications, consist of algorithms. So inventing elegant algorithms that are simple and require the fewest steps possible is one of the principal challenges in programming. How can you be more simple in your instructions? How can you be more clear in your instructions? So that's important. The image that you can see right now is about a certain multiple routes, especially when you're using a website like this sakai.ph. So if you're practicing on how to commute, but this time it's really difficult to commute in this time of pandemic. So if you're using this website, you're given some options. So you see different colors, and this would be very much be familiar to you when you use like delivery apps like Grab or Food Panda. You would see the routes. So essentially, the routes, the different turns that they have to undergo, and probably the time allotted for each step is all also considered as an algorithm. So these directions, though different, are all algorithms. They all have the same goal, but few of them is more efficient or maybe less expensive than the others. So it's really up to the user maybe, or it's really up to the efficiency of the mathematics there, which one is the more plausible for the user to use. So in this example, I think the top route would be the blue one, okay, and this could be the least expensive and probably the most efficient of all. Now you would wonder, what are the ways of writing an algorithm? So as mentioned before, you can write the algorithm in natural language, pseudocode, flowchart, and programming code. So when you write an algorithm, first one is natural language. So if you've seen recipes, if you've seen certain steps in a certain manual, maybe, so that's already an algorithm written in natural language. Next, pseudocode. Pseudocode is an instruction written to mimic actual programming, yet does not really follow the language's rules nor can be understood by a computer. So this could be done using maybe an informal language. It could be a mix of natural language and maybe some technical terms used in coding. So pseudocode. So that's, you can even shorten your instructions, maybe to the point of at least you and probably a teammate maybe in coding can understand. And next we have flowchart. So uses predefined symbols to contain steps of an algorithm. The symbols even more simplified the presentation of the algorithm. So instead of reading text, you're shown pictures or maybe symbols in order to follow a certain instruction. And lastly, this will be the most used way of writing an algorithm, that will be programming code. So for this year, we're going to use Python in writing our instructions, especially for the computer. Now, to show you some example, this would be a pseudocode for a particular program. So step 1, enter number of participants. Step 2, enter number of plan groups. Step 3, divide number of participants by number of plan groups. Step 4, if there is no remainder, display number of participants per group and skip to the end of the program. Step 5, if there is a remainder, deduct the remainder from the number of participants. So if you notice, I tried to shorten some text here. Like for participants, I used the abbreviation, which is PAX. And I tried to use also some terms that I would use probably in my programming. So if you enter this to in your computer, this would not be properly understood immediately. So And essentially, your computer doesn't understand this yet. No, you have to convert this into an actual programming code. And to do that, you have to write something like this. Okay? So, don't be anxious, or don't be scared with by seeing those codes. Eventually, you're going to write hundreds of them, and you wouldn't know that you're actually understanding how to communicate with the computer using Python. So, if you have previous programming language knowledge, and Python would be one of the easiest one to remember or understand and probably learn. Okay, so I don't know if you have an idea how this program works, but this program essentially is used to determine the number of participants for each group. So you don't need to, it's like a calculator for groupings. Now, in this slide, you would find different colors or text or names for colors, and they're colored in different ways, right? So the first two lines, I try to read aloud the color of the text. Now, when you're done reading it, I hope you did not struggle so much, but I'm expecting you to really struggle in reading those texts, because this is what we call the Stroop Effect in psychology. So essentially, our brains are really wired to actually determine the to read the word first before really identifying the colors. So if you reach the part where you find the blue, purple, green, red, so instead of reading this, you have to really read the color of the text, which is green, and we have red, we have purple, we have blue. It really is really difficult to read it, especially if you want to challenge yourself to read it as fast as possible. Now, why am I showing you this? Okay, so I want to show you this because you would probably appreciate more instructions done in flowchart symbols. So here we have different symbols for flowcharting, and I don't know if you have programming experience before or you've seen these symbols before, but we have to really follow at least a certain standard when creating our flowchart. So we have the terminator as our start and end. Arrow lines are important to show you directions for the next steps. We have input or output data, because essentially when we code, normally we input something and we get something out of the program. We also use the process symbol, which is a simple rectangle shape. And lastly, we have the decision or branch question, when we want to add some decision or branching in our process for our flowchart. Now, showing you this example, we have the sample flowchart. Start, input, hourly pay, input hours per week, then hourly pay, hours per week, weekly pay. If weekly pay is greater than 400, you go to the true. So output can afford to live alone. Or if it's less than 400, probably you don't afford to live alone, and probably you need to share a room with somebody, or probably stay in your parents' house. I don't know. So this would be a sample flowchart for it. So when following a flowchart, or when creating a flowchart, of course, these guidelines are important. So I want you to read through this. So only one start and one end symbol should appear in a flowchart as much as possible. So if there are multiple paths going from a certain step, then you must use the appropriate symbol for it, and especially like the decision symbol. But as much as possible, make it clear that you should only use that one start and one end symbol. Next, do not use overlapping lines or arrow lines when creating your flowchart. Creating intersections would confuse your readers, would confuse the ones who will follow your instructions. Next, we have another flowcharting guideline regarding on symbols. So, how to use a decision symbol. You have a diamond shape. So, you try to use the corners or what we call the vertices of this diamond symbol to connect our lines from it. So, we can have one input or incoming process. So, coming maybe from the top or from the side. Then, we try to connect an outputting or outgoing process by connecting also to other vertices. So as much as possible, we try to maximize the number of vertices that our diamond has, which is simply 4. Okay. Another flowcharting guideline regarding the difference maybe between the rectangle and the parallelogram shape. So you use the rectangle for process only. So if you're just not if you're not inputting something or outputting something, maybe a process will do. So maybe like for example, one of the step in taking care of yourself or maybe avoiding contamination for COVID would be washing your hands. So maybe wash your hands thoroughly as a step is just using process symbol, which is a rectangle. Now, if you're inputting something, probably this would be using some soap or apply soap. That would be like an input to your process. So if you're trying to input or output something, use the parallelogram shape. So I hope you are a bit familiar now in using Google Slides. So there is an activity that I need you to make, the exercise and the hands-on activity for making a flowchart. So we have to create a flowchart using Google Slides instead. So to use it or to create a flowchart in Google Slides, just find the symbol in that arrow. So we have a circle and a square. So that would lead you to insert shapes for flowcharting. And if you notice, under the shapes options, you would already find some flowcharting symbols on the third group. So you would, under the third group, if you hover on those shapes, you'd find the names also of those flowchart symbols. So I want you to do this. It's a practice only. So it does for exercises. It's not graded. So you can use it to practice in creating your flowchart or other activities. So for this one, I want you to know, or I hope you know how to cook rice. So I want you to create a flowchart using the steps or procedures that you made in cooking rice. And this for HOA also, HOA 1, as much as possible, try to submit it within the deadline. So I want you to access the assignment post for this and to create the flowcharts given in that assignment post. So before I end this video, do you think after you have made your instructions, do you think a robot can understand your instructions? And if you notice, robots are non-living things, right? So it's unlike humans or other animals that can actually think. So if you give them instructions, would they be able to understand you? So here's Marissa Mayer, Google's first female engineer, and she was once the CEO of Yahoo. So she said, I took a computer science course to fill a prerequisite at Stanford, and I realized that every day was a new problem, and every day you got to think about how to solve something new, how to reason through something new, how to develop an algorithm to solve for something you hadn't worked on before. So I hope you have an understanding now what algorithms are, and I'll see you in next week's lesson. Thank you and goodbye.